Always, guys. Cool. So look, we're doing exponentials now. So exponential function is quite easy to actually see. So here, just know that the x variable. So x, which is a oh my word. Okay, it's fine. X, which is a variable, it's a what? It's an exponent. That's how you spot an exponential function. When you see x being an exponent, then you know. This one here, we have what? We have exponential function. And then, of course, now when you see an x variable as a denominator, then most probably you have a hyperbola here. Do you know what I mean? Sure. Yeah, hyperbola, x is a denominator, and then parabola, x is a numerator with a power of 2, and then linear, x is a numerator with a power of 1. Beautiful. That is beautiful. So let's talk about exponential, man. Like I've already said, this is x variable is your exponent, which is now we all understand. And then we have a couple of these guys, right, and b as well. We're gonna talk about them. First, I'm gonna start with this guy. He's the easiest, right? Let's say we spoke about him a little bit in hyperbola. We said he's what? He's the asymptote, right? So remember, it's only for hyperbola and exponential for grade 10. Oh no, we're also going to talk about trigonometry, where we talk about tangent functions. So of course those three then are the ones that have the asymptotes, right? So here we still talk about the horizontal horizontal asymptote. Asymptote, right? And therefore, by it being a horizontal asymptote, it is responsible for a vertical shift, right? And yeah, it's responsible for the vertical shift. It is yeah it's responsible for the vertical shift, and it is the horizontal asymptote, right? Makes sense. Cool. Now let's talk. Let's talk. Okay. So now, like, I can't talk about A only without talking about B, yeah? But before I go to them, I will say for Q, guys, just remember, if you see that your graph has been shifted a couple of units up or down, then you know the shift has happened, right? So the effect of Q has already happened, right? Yeah, that's the main thing for Q, right? Now for okay, I think for A I can attack it, ne? So A, let it be something that tells you in relation to your asymptote, where is your function going to be, ne? Yeah, just like that. So in relation to your asymptote, where is what are the effects of A, right? So now I will say, if A so say A is smaller than 0, that means A is negative, right? Then you have your function will be y. It's going to be below the asymptote, right? Did you hear me? Your A is negative, your function is going to be below your asymptote. And of course, the opposite is true. If A is positive, then it's going to be above the asymptote, right? So that is just A, right? That is just A. And then let's talk about B. So B can have two possible values. The first value is anything above 1, B greater than 1. And then the second thing is B being between 0 and 1. right? So what am I saying here? Yeah. So what I'm saying is that b can never be 0 and it cannot be 1, right? It cannot be 0, it cannot be 1, and it cannot be negative, right? Oh my word. Yes, why is this happening? And it's early in the morning, bro. So I have what do I have? I just want to show you something. Say b cannot be negative, yeah, but just say b is negative. I just want to show you something. And of course, we know if b is negative and then we happen to have a x happens to be an even number, we're gonna end up with a positive value after raising the power. It doesn't matter, right? For example, if you have no, what I'm saying doesn't make sense. Yeah, but it does. Say b is minus 2, right? And then x happens to be 4. This is gonna be positive, right? But now if we have x being 3, we know it's going to be minus 8, right? Or which is minus 2 to the power of 3, right? And in this case, this is how we'd handle it. We'd say negative 1 multiplied by 2 to the power of 3, right? Saying that actually b is positive. Don't know if that will make sense, but b is positive. The only thing that's negative is a is negative. But just know that b cannot be negative and it cannot be 0 or 1, right? So and there are a couple of things that happens now with b being greater than 1 and b being what? Being smaller than b being smaller than smaller than 1 and greater than 0. So if b is greater than 1, how is our function going to be affected, right? So I would say we have spoken about q and the shifts. Ne? We have spoken about q and the shifts. Ne? So now there will be a case for this gentleman where a is smaller than 0 and then where a is greater than 0, right? So of course now we know that, like we have discussed, if a is smaller than 0, our graph is going to be below the asymptote, and if it is here, it's gonna be above the asymptote. So for here, b is greater than 1 and a is greater than 0, your graph is going to be something like this, right? Say perhaps this is the asymptote, right? This is what your graph is going to look like. Do you understand? And then here instead it's going to be like this, and in that case would say this, let it be the asymptote, right? It's gonna be below, right? Say you have your Cartesian plane right here, so your graph is going to be below, right? And it's gonna have, you see that negative thing, right? It's gonna be like this. Yeah, that's the shape. And then here, this is the shape, right? Yeah, this is basically what is going to happen. But now let's talk about b, yeah, being between 0 and 1. If that is the case, this is what's going to happen. So when b is now when b is now between 0 and 1, let's say we still have our a being negative, we still have our a being positive, right? So now it's going to be quite the inverse, right? Remember here where b was greater than 1, we had something like this, but here we're gonna instead have what? Remember, you would still have your asymptote below and your graph will be right. So this will be the situation. This is how it's going to be, or the shape your function is going to take. And then here the shape is going to be something like this. Remember here for b it was something like what? It was something like this, right? So just, yeah, and of course you'd have your asymptotes here, you have your asymptotes here. For the positive a, you have your asymptotes here and there, right? That is just with the shape of a parabola. Look, I'm gonna say this, what I'm just doing now, just the value of it is in, sometimes you can do mistakes, ne? Like it's easy. I've done so many mistakes on some of the videos in the past, ne? Sometimes you can do a mistake and it's not that you don't know, bro. It's not that you don't know. You know your stuffs. You are really, really good. You have practice and you are ready to get 100%. But sometimes your mind will just tend to miss a very particular digit, right? You forgot the negative sign and therefore you thought that was positive. You press your calculator gives you the value, you put it there. But then when you draw your graph, then you realize, oh no, man, my graph must not look like this because A is positive and B is greater than 1 and a Q is like this. Therefore, the graph, at least the structure must look something like this. But then you see, oh, then you go back, you see where you made your mistake, right? That's how these things, they can help you, know? Yeah, this is how they can help you. So just be able to know the structure. And yeah, for example, let's have a chat. Right here we have something interesting. You see the function, the way it's given. I love the structure, right? You already see that our graph shifted 2 units below, right? And then here I'm like, I'm only seeing B, right? Yes, this is B, but I have X. But then the thing is, what about my A? Is A equals to 1 or not, right? But let me just show you something. You have done lots of exponents now, and you know that it was a product of 5 to the power of 1 and 5 to the power of x. You multiply, same basis, you add the exponents. So therefore here you can rewrite it as 5, oh lord, 5 multiplied by 5x minus 2. Right, this is sort of what you have, and this is A. So now you see A is what? A is positive, so I'll say A is greater than 0, B is greater than 1. Therefore your function is going to look, it's going to be above the asymptote, that one we know, and the asymptote is going to be y equals to minus 2, right? And then is your graph going to be like this or like this? Ne? So because now you have learned the properties, you know the structure of a hyperbola, you know that your graph is going to look something like this. Do you see? Yeah, it doesn't matter maybe where the x-axis is or where the y-axis is, you just know that this is what it's going to look like. Ne? So let's start plotting it. Yeah, maybe perhaps I can do this. Listen to maybe perhaps Sengesi. And then what do you have? Y equals to minus 2, x-axis, y-axis, right? So you know we have spoken about it, that your graph is going to look something like this. Ne? So perhaps what we can do right now, find the y-axis if there is actually any. So not the y-axis, we don't find the y-axis, we find the y-intercept. So y int x equals to 0, so therefore y equals to 5 multiplied by 5 to the power of 0, minus 2. Therefore you have 5 minus 2, you have 3. So 1 2 3, right? This is 0 and 3, right? And you still remember your function is going to look something like this, right? And because of it being like this, we know we have x-intercept as well. So let's calculate x-intercept. X-intercept y equals to 0. So you have 0, 5, x. Yeah, multiply by 5 minus 2. So this minus 2 goes that side. Therefore, we'll have 2. And then you therefore have divide by 5 both sides. We divide by 5 both sides. We are left with this. Right? Now, what can we do here? Let's see. Now, like, I haven't actually taught this, ne? I haven't taught this, but there's this thing that we call lean, right? It's crazy, but yeah, I think I should make a video talking about it. Perhaps after this, I'm gonna talk about it, ne? I'm gonna talk about it. Yeah. So in short, ne? In short, if you have lean of um 5 squared, right? You can write this as 2 lane of 5, right? So I'm gonna make a video, bros. I'm gonna make a video about these stuffs. Yeah yeah, because you find that in most problems you would use them, like you're gonna use it a lot for exponential functions, right? Yeah yeah. So how does this helps us, ne? It helps us here. So you have ln, you put ln both sides, 2/5, right? Equals to ln 5 to the power of x, right? And then here you're gonna have x ln of 5. Here you're gonna have ln 2/5, right? And then you divide by ln 5, you divide by that both sides, and therefore your answer is going to be, we go here, 2/5 divided by 5, right? So the answer becomes minus 0.569. Let me leave it there, right? Let me leave it there. But I want to show you something. We are calculating x-intercept where y equals to 0. So I go to my function, I'm like 5 to the power of my answer, which was ln, right? Don't plus 1, right? And then here I'm like minus 2, right? Oh Lord, wait a minute. Okay, let's see. Okay, it's almost 2, right? It's almost 2. Oh no, 6.5. Yeah. I was about to doubt my abilities. I'm like, hey, what's going on? So we are minusing minus 2, right? And you see we get 0.001, which when you round it to the nearest, yeah, but you're gonna get 0. Oh, beautiful. So here you have negative 0.569 and 0. Oh, let me do this. And therefore your function is gonna look something like this, right? It will go like that, and here something like this. Now this is it. Cool. So guys, like, let's talk about laws of these, logarithmic rules. They will say, let me just talk about them now, in the same video. So there is one where, like, we would say, let me start with this. Ln of okay, let me start with this one. A over b is going to be ln of a minus ln of b. All right, we have this of a multiplied by b. It's gonna be ln of a plus b, right? And the one we did use, x to the power of n, is going to be n ln of x, right? Let me see if is there any. Okay, if any that I did forget comes, I will write it down. Yeah, but know these things for 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 your exponential function is gonna help you a lot. It's gonna help you a lot. So yeah, do learn them. Do learn these. Let's do this problem. Let's do this problem. So here you have minus 2 times minus 2. So we see that a is smaller than 0, b is greater than 1, and therefore your graph is going to look something like what? Because of smaller than 0, we have our asymptotes, right? And our graph is going to look something like this, right? So it's from you knowing the structure to say this is what my exponential is going to look like before you even plot it down, before you even graph it here. You know the structure because you know the effects of a, you know the effects of b, and you know q. So this is going to be where you have y equals to 6. You know what I'm saying? I bet. So let's cook. So you have your Cartesian plane, right? This is x-axis, y-axis 1 2 3 4 5 6. Yeah, it's fine, doesn't need much. 1 2 3 4 5 6. So this is 6. So you have your asymptote here, y equals to 6 now. And of course, still remember your graph is gonna look something like this. So now let's find our x-axis, y-axis. Oh my word, I keep saying axis instead of saying intercept. We're going to find y-intercept, we're going to find x-intercept. Damn. Y-int, x is 0, right? So therefore you have y equals to minus 2, right, plus 6. Remember, laws of exponents, anything to the power of 0 is 1. So this is minus 2 multiplied by 1, which is minus 2, plus 6, and then we have 4. Therefore 1 2 3 4 here, 0 and 4, that's right, your y-intercept. Now let's look for x-intercept, which where y equals to 0, right? So you have 0 minus 2 3x plus 6. You have 2 3x equals to 6. Divide by 2, divide by 2. Once you divide by 2, you're gonna have 3 this side, right? And here you don't have to use the, okay, we'll try to use them, but of course if you have 1, bases are the same, therefore the exponent has to be the same, right? But say for example, I'm gonna use these lane rules to break this gentleman. So I'm gonna have lane of 3x equals to lane of 3, right? Here I'll have x lane of 3 equals to lane of 3, right? And I divide by lane of 3, lane 3, and then this cancels, and then this lane 3 divided by lane 3 is 1. So it doesn't matter which method you use, it works. So it's 1. So 1, where is it? 1 is here. So 1 and 0, right? Cool stuff. And then what's the next thing? The next thing is that you're going to now plot it, right? We go here, and it continues like that. Yeah, it continues like that. So you can see I didn't talk about it, but the domain for these things, it's always negative infinity to positive infinity. That is the domain of your exponential functions. But as for the y-axis, as for the range, range, you determine it by a. If a, let me do this. So how do you determine your range? A tells you a and q, right? A and q, we have plus 6 here. So a and q, right? If a is smaller than 0, your range is going to be, of course, y. What is y going to be? Because if a is negative, then your graph is below the asymptote. So your graph is going to be from the asymptote to positive, negative infinity, right? And if a is greater than 0, then y is going to be from y to positive infinity. The reason I'm saying that, look at this one for an example. Y values are going to be from y, which is minus 2, all the way to positive infinity. And the previous one that we had, a was what? A was negative. Here's a. And I'll just get to the graph now. You will see that, oh, our graph, your a, it goes from that to negative infinity. Look at it. So we have a be minus 2. So what was I writing? Oh my word. Yeah, ne? No, I'm gonna have to take a break after this. I'm gonna have to take a break after this. So when I was writing the range, and this is what I was saying. I was like, range is going to be from y. Say for example, it's here where a is 0. Ne? I was like, it's gonna be from y to negative infinity, right? Y is an element of. But what I wanted to say, in fact, it was not to put y here. Ne? It doesn't make sense, bro. I wanted to put a. Is it really a? No, it's not a. It's q. I wanted to put q. Q makes sense, yeah, because we are from q, which is 6, but of course 6 is not included, so we move from there, we're going down, right? And if a is greater than 0, come on, bro, come on, Jesus. A is smaller than 0, ne? This is move from q to negative infinity, right? And then if, right, because we move from this side and we go to the negative y values, but then if a is greater than 0, then we have it being to positive infinity, right? To positive infinity. And also, like you start with the smallest, ne? So again, I will say if a is smaller than 0, right, then this be negative infinity to q, right? Yeah, nah. Crazy business. Let's just find the equation of this guy and call it a day, yeah? So for this gentleman, we have, you already know on your function, né? Which is y equals to a b to the power of x, b to the power of x, b to the power of x plus q. You already know that you have what? You have a b to the power of x plus 5. This is where the 5 is coming from, right? And I made a note here that b equals to 2, so you have 2, you have a 2 to power of x plus 5. Then we substitute this value where y is 1, a 2 to the power of 2 plus 5. So you have this side, we have 1 minus 5, which is minus 4, and this side we have 4a divided by 4 a equals to minus 1, and it makes sense, right? So here therefore your function is y equals to minus 1 2 to the power of x plus 5. It makes sense why this is negative, because look, your asymptote and your graph is below the asymptote, and the way it's shaped, it makes sense that this be the function. Yeah, but otherwise, yeah, look, know your things, ne? Know properties of A, properties of Q, because they really help you when it is time to, you won't get lost, and you'll be able to rectify your mistakes. You see, one thing is doing a problem and then only realizing when you don't have time. After you've made so many calculations, then you realize, already you were wrong from the beginning. Now you have to start all over. Trust me, man, you don't want to be that person. So, always.